Okay, so now we're going to calculate the solution to the last problem, and we're going to use the calculator instead. And so I'm going to have to explain lower and upper limits to you, and the mean and standard deviation will be the same for the calculator as it was on the problem we just did. So when you're using the calculator, we have the following picture. And so we have to set what's called a lower and upper bound. Okay. And to do this, you have to. So, what we're going to do is there's different possibilities. If it's a less than problem, for instance, if p of x being less than 35, like this problem suggests, then we want only the values that are on the left of 35. This is what will be the upper bound. Okay, the reason it's the upper bound is the highest value that we want to use for the calculator. Now, we also need to pick a lower bound. Since we want any value lower than 35, because if it's 0 inches, that's probably the lowest. Or, well, probably not the lowest, because if it's a height of somebody, it's probably at least, I don't know, 14 inches or something. I don't know how big the babies are or whatever. But um, with that being said, you need to be able to set a lower and upper bound. And so there's a couple things we have to keep in mind. So when we do this, we need to make sure that this lower bound falls outside of, say, 3 standard deviations or something. So what I typically do is I take the I take the standard deviation is equal to 3.17, and I times it by 10, and so that would be 31.7. Doesn't necessarily have to be 10. You could do 100. You could use 317, for instance. The main goal is to make sure that you get all of the data, because if you choose something that's only 2 standard deviations away, let's say that you choose 2 times 3.17, that's going to give us 4, 2 and 1, 2, 3, 6.34. And so if we say take 6.34 from 38, we have 38.72 and 6.34. This is 6. This is 8. 3, 2, 32.38. So if we're at 32.38, that's 2 standard deviations away. Remember, 1 standard deviation was maybe right there. What's going to happen is we're going to miss this data here. And I'll show you what that looks like on the calculator. So if we're going to use the distribution, we go second vars. This is normal CDF. We typically will not use PDF. And it asks for the lower bound. So let's look at the lower bound when I do 32.38. Okay, that's good. We want the upper to still be 35. The mean, we want that to be 38.72. And the standard deviation is 3.17. We paste it, we enter it, we get 0.09. So when we use lower, 0.0975. Where is this one? Lower at 32.38, we have 0.0975 as our answer. Okay, that would be the probability that they're born less. But now let's see what happens if instead we subtract 317 from this. If we do 317 minus 38.72, we have 6, 9, 8, 2, 8. 278. So negative 278. So if we use the lower at negative 278, 28, let's do it again. negative 278. And I'll just leave it at that because that's pretty far. Oops. Negative 278. Enter. So you'll see that this is now 12 something. And what happened? So what happened was, because on the first time I did this, excuse me, because the first time I did this, I did not get all of the data. I only got up to 2 standard deviations. I missed this part of the data, which was only 3%, but it's still enough to change the probability of this thing. So what has to happen is you have to pick your standard deviation to be far enough to the left that, or I'm sorry, you need to pick your lower boundary to be far enough left that it gets all of the values. And that's why the calculator has that negative 1e99. That's essentially negative infinity. But any number that's outside of 3 standard deviations should get all of the, well, probably 4 standard deviations for sure, will get all of that data values. And you will not have to worry about it because anything smaller than that 4th standard deviation is already pretty much so minute that it won't change the value on a calculator even. And so what you can do is you can do 10 times the standard deviation and then subtract it from the mean. In this case, it might have been wise to just do negative 999 because, I mean, you can really just keep putting nines as much as you want. The only issue with that is that if your mean is at a negative number, negative 9995 or something, and you only choose negative 999, your lower boundary might fall in the range of your standard deviations. So you do have to be mindful of that when you're using negative numbers there. But for the most part, I think if you just use the 10 times rule and then subtract it from the mean, you'll be able to get the value that you want, and you'll be able to have a lower bound that works. Now, obviously, there's other instances. You can have the upper bound. So, for instance, what if we wanted to find between here and here, and this is 30... Now, let's say this is 41 and this is 40. Then what would happen in this case? If you wanted the lower, this is the lower. This is the upper. And so if you use the calculator, you'll just put 40 and 41. So if we go over here, delete. 40. 41. Enter, and we get about 10% of the data in between there. And so we don't have to worry about the lower and upper boundaries so much, like calculating what it should be if it's between two numbers that are given. If it's like, if x, the probability of x, that 40 is less than x is less than 41. If it's like that, then we can just simply enter those values into the calculator. And then obviously you can have the probability that x is greater than 40, which would be here. And so in that case, this is the lower, and the upper should be 10 times sigma added to the mean. And that will give you the upper boundary just to make sure that you get all the values to the right. So I hope that that helps you with understanding this. I know there's a lot on the screen. If you need more help, obviously ask me for more help and I'll try to explain again. Thank you guys.